In this video, I'm going to be looking at our review packet. This is going to be part 2. For number 1, it says, what are the roots of the function graphed below? Do not forget that roots also have different names. Whoa. Roots are called roots. They're also called solutions. They're also called x-intercepts. And they are also called zeros. 4 different names for all the same thing. What this means is just the point where it crosses the x-axis. So in this case, our roots cross the x-axis at -4 and 2, so -4 and 2. We can say x equals, you can say x equals -4 and x equals 2. In this one, we have -4, 0 and 2, 0 is how the options are given to us. So it's going to be H. There we go. There's an H. Ha! For number 4, it asks us to solve the equation by graphing. Well, if we want to graph, we need to know our roots. So either you can use your calculator, and you can go to your y equals, clear everything out, and punch in your equation. So x squared plus 5x minus 14. And we want to look at the graph. Well, I can see that I have a root here, and I also have a root here. But I don't know that those are for sure it, because that might be 2, it might not, I don't really know. But don't forget, we can go second calc and find our 0, because that's what we're looking for. Same names for different things. Solutions are zeros. So if I find my 0, it asks me to do left bound, right bound. Do not forget that you can be only to the left of one solution at a time. So if I'm trying to find this one, I have to be just to the left of that little imaginary line. So there I am to the left, so I say, okay, calculator, I'm to the left. Then it asks me to move to the right. Well, I moved plenty far enough right, and I hit enter. We don't care about guessing, so we're going to hit enter one more time. So x equals 2 is one of our solutions. And then you would do the same thing for the other side. Second calc, 0, blah, 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 move over so that you are to the left of this 0, and then to the right of this 0, and then it will also give you x equals -7 is another 0. So we have x equals 2 and x equals -7. The other way of doing this is just by factoring it, like we already know how to do. That was on the Unit 8 test that we all loved. Yes, best thing ever. We know it's going to start out as x and x. We know that our signs have to be different since they multiply to be a negative. So now I need 2 numbers that multiply to be 14, whose difference is 5. Well, we already know it's going to be 7 and 2, so I can just use 7 and 2. Since I have something times something equals 0, I can take both of those somethings and set them to 0 themselves. So x plus 7 equals 0, and x minus 2 equals 0. So x will be -7 and 2. Well, now I just have to graph this stuff. So I know it's going to cross at 2. I also know it's going to cross at -7. And then I just kind of draw a parabola. Yeah, that looks pretty close. Cool. Yay! Number 8 is a little bit of an interesting problem, so I'm going to go ahead and look at that. And it is interesting because I only have one variable that I can see. I only have this x right here. There's just a lot of stuff around it. But I can solve for that x, and first thing that I would need to do is divide by 4 on both sides. So if I divide by 4, I have 3x minus 2 squared equals 36 divided by 4 is 9. Well, now I need to get rid of the square up here, because that's the next thing that's kind of bugging me. I can't really just add 2 because it's inside the parentheses. So if I take the square root of both sides, don't forget we have to add a plus or minus, and we take the square root. So I have 3x minus 2 equals plus or minus 3. And then it's just a matter of getting everything away from x. So if I add 2 plus 2, then I'll have 3x equals 2 plus or minus 3, and then divide by 3. Divided by 3, so x equals 2 plus or minus 3 divided by 3. So do not forget, you still have to split this up as 2 plus 3 divided by 3, or x equals 2 minus 3 divided by 3. So we could have 5 over 3, or, was that -1 over 3? 1 and 2 solutions. Looks like it's going to be C on that option. Okay, you can also do this by just putting in your calculator and finding the zeros that way. It's just as simple as this. Okay, looking at number 10, because it covers a lot of information in one problem. Jake studied the parabola shown below. Which is an accurate conclusion that Jake can make about this parabola? Well, A, the vertex is at -2, 0. Well, -2, 0 is right here. Is that where our vertex is? No, because the vertex is the point where it turns around. So the vertex of this parabola will be right there, or of this one, it will be up here somewhere, the point where it changes direction. Number B, or letter B, the minimum value is at 0, -4. Well, if we look at this thing, it goes down to a value, stops, and turns around. Well, that's a minimum, so it looks like it's going to be 0, -4, so we're going to go with B. B will be the solution. But I want to keep looking. It says the maximum value is at 2, 0. Well, there's 2, 0, and that's not even a point on our parabola. Do not forget, this one is a maximum. When it goes down to a point and turns around, this is a minimum. So maximum, minimum. The axis of symmetry is the x-axis. The axis of symmetry is actually, on your parabola, the point, or the imaginary line that runs through the vertex over which your parabola is reflected. So here's the axis of symmetry, because we could fold this side over the parabola over onto the other side, and then it will be the same object.